In this set of videos, we are going to start talking about how you traverse a graph, or how you explore a graph, or how you search a graph. All of these are synonyms for saying how programmatically can you see what structure a graph has or learn things about that graph. The fundamental idea here is a graph search, where you're trying to somehow move around the graph. You're trying to determine something like, is there a path from A to B? Trying to determine what is the shortest path from A to B. Trying to determine if the graph has cycles, or if the graph is a tree, or if the graph has A, B, C, D, whatever property you're trying to discover. A graph search is in some sense one way to do this. The other way would be to analyze the adjacency matrix and try to determine things about the adjacency matrix. I'm not assuming that you know linear algebra, so we're not going to go down that rabbit hole. So instead, we're going to focus on the more programmatic approach of looking at a graph and talking about how do you explore it. As an idea of what do we mean by a graph search, what I mean is somehow you need to determine what is happening in a graph. For everything going forward, we are going to assume that we have an adjacency list representation for our edges. That means that if I want to explore the graph, I cannot access the edges without starting at some vertex. The only way that I can deal with anything to do with the graph is to start at some vertex. So imagine, if you will, that we start at vertex 1. We then need to find out something about the graph. The only way to do this is to go to an adjacent vertex. There is no other option within an adjacency list. So we will talk about two main ways of doing this. One is going to be called breadth first search, which functions on the idea that from 1, you have 4 options, going to 2, going to 3, going to 4, and going to 5. Why not try all of those first and then see what else happens afterwards? So that's one option. You only check the things that are immediately adjacent and then proceed in some like manner. The next one is you just choose one of those edges and start going down that path and see where that leads you. So the other option would be, starting at 1, choose at random one of these, maybe 4, and then see where 4 leads you, then see where 7 leads you, and then just keep moving around and see what happens. That being the idea behind depth first search. So those are our two main ideas, is you can either explore everything directly next to you, so you look at all the things right by, or you say, I'm just going to start walking in some random directions and see where I end up. Trying to keep track of something so that you manage to not sort of end up back where you started and then just keep going in circles indefinitely, because you want to explore the entire graph. So we're going to see two implementations, breadth first and depth first search, for analyzing this idea.